Assalamualaikum and a very good day to everyone. So today we will study about one of the construction planning techniques in a construction project management, which is critical path method, or we can call it as CPM. So CPM can help plan and control projects by improving our understanding of the entire project. CPM is based on a logical network with a diagram drawn using certain symbol. This called as a network diagram. So the network diagram is a network of activities of project implementation that is arranged in a logical sequence. The critical path is the lengthiest set of tasks to be completed in a project from start to finish. The tasks on the critical path are known as critical activities. The entire project will be delayed if these critical activities get behind the schedule. By identifying and calculating the critical path, we can determine the total duration of the project and the critical activities that must be on time. Once a critical path is determined, we can see the clear picture of the project schedule. Next, we go to the usage of CPM. Basically, we have 5 usages of CPM, which is identify the tasks required to complete the project and the dependencies between each other. Then, we use the CPM to calculate how long each project task will take. Next, we use CPM in determining the critical activities by calculating the critical path based on the task duration and dependencies. Fourth, we use CPM to focus on planning, scheduling, and controlling critical activities. And lastly, we use CPM to establish time frame for the expectation of stakeholder. Before we go to the procedures of CPM, we must know the term in CPM. First, we have network diagram. So network diagram is a logical sequence of the tasks. It displays the order of activities from start to finish. There are essential two methods used to draw the network diagram, which is ADM and PDM. I will explain what ADM and PDM right after this. So the network diagram will use three symbols, which are arrow, nodes, and dash arrow. Arrow. So arrow is a symbol that indicates activities that require time and other resources. These arrows are drawn not to scale, and the name of the activities is on the arrow, and the arrowhead denotes when an activity ends. Nodes. Node symbol indicates the activity that shows its duration and intersects with the activity's begin or end. The activity at the arrowhead must be greater than the activity number, which is the earliest and the latest time. Dash arrow. So dash arrows indicate a dummy activity. A dummy activity is added to show dependencies between the activity, but it's not an actual activity. It is to retain the proper sequence or to divide tasks into independent nodes. A dummy task often has zero duration. Explain you what is ADM and PDM. So basically, ADM is standing for arrow diagram methods. So ADM is composed primarily of arrow and nodes that are also known as AOA, or we'll call it as activity on arrow. So one activity is represented by one arrow. The activity's begin and end points are represented by the arrows starting and ending points respectively. The length of the arrow indicates the activity duration, and ADM only shows the finish-start-finish relationship between activities. Next is PDM, which is precedence diagram methods. So PDM is also known as activity on nodes, AON. So PDM is a different type of network where activities are represented by nodes and linked to one another by arrows. So these arrows show the linkage between various activities which are finish to start, start to finish, finish to finish, start to finish relationship. Now, we can go to CPM procedures. So basically, we have 7 steps to do the critical path method. First, we have to identify the activities. So list all the activities that are needed to complete the project. Then we have to calculate the activity duration. So calculate the activity duration considering the crews and the amount of work. The activity duration will affect the length of the critical path, hence estimating the activity's duration is a crucial step. There are methods for calculating activity periods as an expert assessment, analogs estimating, parametric estimating, and 3-point estimating. After we calculate the activity duration, we can continue to identify the logical sequences. The logical sequences to find the predecessor and the successor activity. So, to do the identify logical sequence, we have to answer the following question, which is, which task will begin first? What activity will start simultaneously? Which task will end immediately following this one? What task will begin right after this activity? Then, when you can identify the logical sequence, we can go to the another step, illustrate the network diagram. So we draw the nodes for the activities that mark the start and finish of such an activity. Determine whether it will use ADM or PDM. So these nodes divide up the many activities. So use dummy activity if necessary and display them as a dashed line. Next, we can calculate the critical path. So how to calculate the critical path? So calculate the critical paths from the network diagram by using forward pass and backward pass. For the forward pass, we will calculate from left to right. And it's a technique where we can find the earliest event time, while the backward pass from right to left where we can find the latest event of each activity. After we calculate the critical path, we can calculate the total float and free float. So this is also known as lag. Total float is the amount of time of an activity can be delayed without delaying the project's duration. So total float equal late start minus early start, or late finish minus early finish. Free float is the amount of time that a task can be delayed without affecting the early start of the succeeding activity. So free float equal to early start of the next task minus early finish of the current task. After we identify the total float, we can identify the critical activities and critical path. So how can we identify the critical activities of critical paths? Is when the total float of the activity is 0, then the activity is a critical activity, and the critical path is a path of the critical activities. Have you understand CPM? No worries. I will show the example of CPM by using ADM and PDM. First, we will start the example of CPM by using ADM. So let's look the example on table 1. So this table 1 have activity, event, and duration. So this table have covered our step 1, 2, and 3. Next, what we must do next? Next, we have to illustrate the network diagram as in figure 1. So as you can see in figure 1, we can see that events 1, 2 will denotes activity A, and the brackets beside the activity A is the duration of the activity. So we have events 1, 2, activity A, event 2, 3, activity B, event 2, 4 is activity C, event 3 to 4 is activity D, and that is dummy activity, so the duration will be 0. Then we have event 3 to 5 represent activity E, event 4 to 6 represent activity F, event 5 to 7 represent activity G, and event 6 to 7 represent activity H. After we illustrate the network diagram, we can do the forward pass calculation. That is the step 5 in doing CPM, which is we calculate the critical path. So how we calculate the critical path? We have to find the early start and the late start of the activity. So for activity at the event 1, we can see that the early start and late finish. So we will assumption that event 1 is the starts of the activity. So the early start will be 0. Then at event 2, the early start will start on day 2. How we get day 2? It's 0 plus with the duration of activity A. Then we got the the early start on event 2 is 2. And we can continue until event 7. And we have to bear in mind when doing forward pass, if there is two numbers or two different numbers from other activities, from previous activities, we have to choose the greater number, which is, as example, in event 4, we have previous activities from event 3, which is activity D, and we have from event 2, which is activity C. So activity C is an activity that take 4 days, while activity D is a dummy activity, so the duration is 0. So we have 5 plus 0 is 5, and 2 plus 4 is 6. So which one we have to choose to get in the early start of event 4? We have to choose the greater number, which is 6. And then another example is on event 7. Event 7 can get from event 5 and event 6. So we can get that event 7 from 5 is activity G, and event 7 from 6 is activity H. From these two, at activity G, we will get the early start is 12, and from activity H, we will get the early start is 17. So we have to choose the greater numbers, which is 70s. So from this calculation, we can get that the total duration of the project is 17. Next, Let's do the backward pass calculation. So the backward pass calculation is from right to left. So how we do the backward pass calculation? So we can start from this node 7 and event 7. So we have 17 for the ES, so we will take the late start also 17, and then we subtract with the duration of the activities, which is 17 minus 5, and we will get 12 for late start of event 6. And we continue to the others until we get the late start at the event 1. Then we go to the final step, which is step 6 and 7, where we have to find the total float or the slack time. So when the total float is equal to 0, it will indicate the activity is a critical activity. So we can see from figure 4, the total float at nodes 1, it's 0. Also the nodes 2 is 0. Nodes 4 is 0. Node 6 is 0. And node 7 is 0. So automatically the event 1, 2, 4, 6, and 7 is a critical path. And the critical activities is the activities on the critical paths, which is activity A, activity C, activity F, and activity H. While we go to node 3, we have slack time 1, which means this event can be delayed by 1 day. And for nodes 5, we have 5 days slack time, which means this event can be delayed by 5 days. So this is the example of CPM of using ADM. Now we go to an example of CPM by using PDM. Basically, the process is similar with this ADM, but there are a slight difference in the network diagram illustration. So we have table 2 here. Also from this table, we had complete the step 1, 2, 3, which is we have the list of the activities, we have the predecessor, the logical sequence, and we have the duration. And next, we do the network diagram. So the network diagram based on the table 2 will come like figure 5. So we have activity A, first start activity, and activity A will come out with activity B and C. Means activity B and C will start after activity A finish, while activity D will start when the activity B finish, and activity E will start when the activity C finish, and activity F will start when activity G and E finish. And go to the next step, which is to find the critical activities. So we do the forward pass when left to right, and we have to take the biggest number, same as the process in CPM using ADM. But in PDM, we have 4 dependencies, which is we have early start, late start, early finish, and late finish. So we will have 6 boxes that will represent early start, and will represent early finish, and at the bottom will represent late start and late finish. So that is the activity A, and this bottom is the duration of the activity. So how we calculate? So we can get the ES equal to EF of the previous activity, and EF equal to ES plus duration of the current activity. So we can see at activity A, the EF here equal to ES plus the current activity plus the duration of current activities is 1. So we get the EF is 1. For activity B, we get the ES for the activity B is the EF of previous activity, which is 1. So we get 1 here, and the duration of activity B is 2. And we plus 1 plus 2, and we will get the early finish for activity B. And we will continue this until activity F. And we have to bear in mind, when there is two numbers between the activity, we have to take the biggest number. As example in activity F, so it comes from activity D and activity E. Activity F must start when both activity is completed, which is activity D and E completed, then the activity F will start. So we can see that at the activity D, the early finish at activity D is 9, and the early finish on activity E is 4. So we have to take the biggest number to make sure both activities completed when we start activity F. So the early start for activity F will be 9, and we add with the duration of the activity F, and we will get 16. So basically we have the total duration of this the total duration of this project is 16. So next we do the backward pass. So as I say before, it's also the same in the ADM techniques, but a little different because we want to find the late finish. So the late finish equal to late start of previous activities, and late starts equal to late finish minus duration of current activities. So we can start from activity F. So the late finish is 16, and we subtract with the duration of the current activity, we get the late start is 9. Then for the activity D, we get the late finish is 9 because it comes from activity F. So subtract with the duration of activity D, which is 6, so we will get 3. And for activity E, we'll get the late finish is 9 also, and minus with the duration of activity E, we will get 7. And then we go to activity C. So activity C, the late finish is 7. We get from the activity E, and minus with the duration 1, we will get 6. Then we go to activity B. So activity B, the late finish is 3 because it comes from the previous activities is D. So so 3 minus 2, the duration of activity B, we will get 1. So here we have two numbers, so we have to choose the smallest numbers to get the late finish of activity A. So we have here the smallest number here is 1. So we get the late finish of activity A is 1, and minus the duration of the activity 1, so we will get 0. So from this, we can get the total float or slack. So we can get the total float will be equal late start minus early start, or late finish minus early finish. So we can see the total float for activity A is 0, the total float of activity B is 0, and the total float of activity D is also 0, and activity F also the total float is 0. So automatically the path of A, B, D, F is the critical path. So the duration of this path cannot be delayed, because if you delay the duration of these activities, it will affect the total duration of the project. So while we can see at activity C, the slack time or the total float is 5, which means it can be delayed by 5 days, and activity E, the total float is also 5. So both of these can be delayed by 5 days. So, can you differentiate between ADM and PDM while using critical path method? No worries, I have prepared a table that differentiates the ADM and PDM with the various aspects. So we can go to aspect basic representation. For ADM, uses arrow lines to represent activities and nodes to represent events or milestones. While in PDM, it uses nodes or boxes to represent activities and arrows to represent dependencies. In activity representation, ADM activities are represented by arrows that connected nodes, event, and for the PDM, the activities are represented by nodes, boxes, connected by arrows that represent dependencies. Whilst we go to the dependency types, in ADM, uses finish to start relationship by default, and it can represent other relationship like start to start, finish to finish using arrow notation. In PDM, that allows for a more flexible representation of dependencies, including finish to start, finish to start, and start to finish. And we go to the aspect complexity. In ADM can become a more complex when representing multiple dependencies types and more require additional notation for clarity, while in PDM provide more intuitive and flexible way to represent various dependency types, reducing complexity in many cases. While in logic representation, ADM often requires additional explanatory text or label to describe the logical relationship between activities, while in PDM uses clear arrows and dependencies directly between nodes, making the logical relationship more visually intrusive. And in critical path calculation, ADM calculate the critical path by identifying the longest path through the network using the early start, ES, and late start times. While in PDM, calculate the critical path by using the critical path algorithm, which considers the earliest start and finish time and latest start and finish time. And the notation for ADM typically uses activity on arrow or A notation, whilst in PDM typically uses activity on nodes, AON notation. So you have clear picture the differences between ADM and PDM. Guys, we come to end of our lesson today with the conclusion. So we can see that the critical path method, CPM, is an essential tool in a project management that helps identify the critical path within a project. So these critical tasks are the one that, if delayed, will result a delay in the project overall completion. And CPM involves creating a network diagram that is depict the tasks and their dependencies, estimating the time required for each task, and determining the critical path through the project network. So we have learned today the network diagram in CPM. You have two types, which is ADM and PDM. So by focusing on the critical path, the project managers can allocate resources, set realistic timelines, and mitigate risk to ensure the successful of project completion. That's all for this lesson. Thank you.